Okay, so let me hope how this gets recorded properly, so I don't have to re-record after class today. So we are going to I have some questions I just sent you. I posted it here also under final exam. Let me see. So go all the way to assessment, then final exam, you have final exam review. So I have this Word document here. So I'm going to open it. I sent it to you also as email. So those are just like few highlights of things I want to kind of touch. But also send yours, like if you have any question that you want us to highlight next class, send it between now and Thursday morning, let's say by 8 a.m. That way I can organize them properly before class starts, okay? So, but I have a few here. I'm hoping these few will help you. And we're going to walk through them, except if any other concern arises. Okay. So I wanted to first ask, just trying to be precise, I'm really focused on making you successful, helping you to be successful in the class. Believe me, that is my drive. And that is why all these things will be built in. For example, we are reopening homework. For example, you can take quiz 2. So all these things are meant to kind of make sure that if towards the end of the class you've learned the material, the difficulties that we are expected to have at the beginning doesn't affect your final grade, right? So I really hope you work hard on this one and then use it to balance whatever is outstanding, okay? So before quiz 2, I got 2 emails about calculator not being allowed. More than 2 persons may have a concern about that. And then this one, after sending out the instruction also for the outline for the final exam, I got 1 email about that, right? And I know that I've sent email before explaining the rationale for not allowing calculator, scientific calculator in this section. So I just want to give you opportunity, and I did ask if you could send me example of the questions where scientific calculator would really like have a different learning help that is different from what we have learned, you know. So I know when we are learning in class, we have used tables, tables, we've used normal tables, we use Excel, and when the need arises, we've also used the computer calculator, right, which is like the kind of 4-function calculator that I'm hoping you'll be able to use, right? So if after class today, thereabout, send me a question, right? So I want to be able to look at that concretely, objectively, right? Because I know I didn't teach with any scientific calculator. So send me a question that solving a scientific calculator will give a learning advantage that cannot be obtained from solving the way we are solving in class, okay? And I will consider that, and by Thursday, if I got legitimate questions, I will remove that aspect, right? But right now, if you ask me, when I look at the exam, I don't think having scientific calculator is going to give you any advantage, right? When I look at the exams, but I know it's hiding some of the things we are testing. I know that you can get confidence interval from the calculator straight, but it will not give you critical value. It will not accept. There are other calculators that can do that, but the TI-84 I don't think does. Critical value, margin of error, confidence level, just understanding those concepts in between before you get to confidence stuff. So we're trying to test for those things, okay? I have this explanation on email I sent you during quiz 1, but I'm explaining again because it popped up this time also, okay? So just send me a screenshot of a question that you feel using scientific calculator will give you a learning advantage other than what we have used, the approach we used in class, okay? All right, so I will go through some of these questions today. They are just sample questions. Don't take them as the exact thing that will be on the finals, but they are sample questions. And you know, if you look at our quizzes, they don't go far away from the homeworks, right? So a good way to actually review for the finals is, okay, I looked at the syllabus and I found out that, let's open one very quickly. Okay, it's taking some time. Okay, so I looked at the syllabus and I found out that the exam starts from section 2, right? And if I look at section 2, the first thing here is binomial distribution, right? So I'll go to my MATLAB and look for where I have binomial distribution. And I think it's also on section 2. So let me kind of close some of this so that it could minimize that. I opened almost all of them this morning, so they are over the place. So it's also on section 2. I will open section 2 and look for the chapter on binomial distribution. Let's open this also. So it's here on chapter 4, right? So I will open binomial distribution and kind of review. There's only one homework here. I'll kind of review the questions here, right? I kind of see if I can solve these questions. If I can solve these questions, it means I'm actually comfortable with the kind of questions I will see in binomial distribution, because I'm not going to like go out and pick something that's entirely strange. I'll just pick one of these questions and maybe tweak it a little bit and ask you to respond to it, right? And then you continue the same way, right? Look at the syllabus. The next thing there is normal distribution, right? So we have normal distribution for 3 weeks because we cover different aspects of it. And then you have central limit theorem, right? So if you look at those will be from chapters. See if I can go back this way. Yeah, so those will be from chapter 5 and 6. Chapter 5 and 6 cover central limit theorem. So I will open that and look at the homework and pick random questions and just be sure I'm comfortable with the concept there, right? If you follow this strategy, you'll be fine on the exam. I'm not going to pick, like you've seen the quizzes and the midterm, we didn't pick anything strange, right? So, and you also allowed 2-page formula sheets as before. Yes, please. I will try to break them up, but no, so it's not going to be unit by unit, right? So it's going to be section by section, okay? So I'll try to break them up in section, at least to kind of give you some kind of framework, right? Yeah. Yes, so there will be 4 sections on the finals, right? And according to the instruction I sent you already, so you could tell that section 1 is taking question from, so I'm calling them parts, not to confuse them. You see that part A is taking questions from section 1. Part B is taking question from, part A is taking question from section 2. Part B is taking question from section 3. Part C and part D is taking question from section 4. But if you come to section 4, as I mentioned earlier, and also in the instruction, we are testing for 2 things, right? We're going to be testing for understanding and interpretation of regression, linear regression outputs. That will be unit 11. And then the last section is testing for understanding and interpretation of analysis of variance. That will be unit 12, right? So, and what we're going to try to do today is to see if we can capture section 2 and 3 in our review today. Next Thursday, during the review, we capture section 4, which will be unit 11 and 12. right? Okay, so that is the way it is. So I'll try to structure it that way, but your questions are going to be random. You see the structure of the quiz too, right? So somebody beside you is not going to be doing the same thing as you're doing. And the section might be shifted, right? But the questions will be together. So if this is part A, and it happened to be dealing with section 3, all the question in part A will be coming from section 3. But for somebody by your side, it could be that their own part A is dealing with a question from section 1, but section 2, but all their question in that part is coming from section 2. So once you open the quiz, it will go page by, final exam, we go page by page. Each page will cover a section of the work, and the questions will be similar. At least that will give you some structure and some frame of mind when you are responding. Okay. Somebody else raised up hand. Yes. Okay, so that is a good question. So quiz 2 captures section 3, right? Section 3 gave itself to that kind of structure because in section 3 we are dealing with confidence interval, hypothesis testing in 1 sample, hypothesis testing in 2 samples, right? So instead of giving you 3 different questions in the quiz, I selected to randomly give each person 2 of these 3 topics, right? They're in chapter 7, 8, and 9. So each person got 2 of these 3 topics questions. So, but this is final. We are trying to cover much more space. So I'm going to be picking 1 of the 3 topics in that section. But yes, so it will be a scenario question. So I will pick 1 question, which will be randomized across. So somebody by your side might be getting independent sample t-test. Somebody on the other side might be getting paired sample t-test. Somebody might be getting confidence interval, but randomly, each of you is going to get 1 question from that section. Then that 1 question will be a scenario that will be described. Now it's not left for you, part of what is being tested, just as we did in quiz 2, it's left for you to know, okay, this description fits a paired t-test. So if I'm responding to all the questions below, I'm going to be using the knowledge of paired t-test to do that. Or this description fits the definition of definition of independent t-test. So when I'm responding to the question, I'm going to respond that way, right? But so it's going to be similar. That is section 3 only. So section 3 will contain a scenario question. It's going to be only 1. In the quiz, we did 2 scenarios per person, actually 3 scenarios per person, right? So, but in the final, section 3 will have only 1 scenario, but that 1 scenario will be randomized. So each person will be doing different things, right? But once you have the scenario, the questions underneath will be focused on that scenario. So you might have like, say, 5 questions underneath it. All of them are dealing with the scenario you are giving, okay? Then section 2, section 4, we all have their question as I described earlier. Okay, yes, go ahead first. Mm-hmm. Mm-hmm. Yeah, so each of them appeals differently. So, section 1 is more of multiple choice question. We are defining concepts. We are talking about things that are fixed. For example, if you say calculate the mean, there is no other way to calculate the mean other than just calculate the mean. But when you move to section 3, we started having logical thoughts into the expressions. So the question is going to follow that pattern, right? So that is why you see that quiz 2 had a different structure because we needed to learn to distinguish between the different type of tests, and we needed to learn how to apply the concept underneath each type of test. So I would say questions from section 2. Questions from section 2, we have, because those are little kind of, so from section 2, we did binomial distribution and normal distribution and central limit theorem. Those are the three topics there, right? From that section, the question will be there could be some multiple choice, right? Testing concepts, and there could be questions, calculated question where you solve and then type in your answer, okay? Just like we did in quiz 2. So it will be a mix of those. And then, of course, section 4, which we include 2 parts. One part is linear regression, the other part is ANOVA. That section will be focused on interpretation of the output, right? So I gave you this SPS lesson work to do, and you've posted, if not that you still have time to do that, right? So those outputs you generated from SPSS, if I'm doing data analysis after this class and I run a regression analysis, am I able to look at my output and pick up what I need to do interpretation, right? And that's what we did in class, right? We picked up, say, tell me this is R square. We said this is the value, this is how to interpret it. This is p-value for SIG in SAS output. This is how to interpret it. So it's going to be something like that. I'm going to be testing whether, are you able to look at this output and say, oh, this is R square, this is p-value, and this is my conclusion based on the output, and this is my result. You know, just the way we did on the homework, it will be a replication of that. So in answer to your question, in summary, each section we mirror the kind of knowledge that was conveyed. Where just concepts were conveyed, it will be multiple choice. But where there are more logical reasoning to get at the information is conveyed, then there will be like calculated question, right? And pay attention to how to interpret results, right, from SPSS and from, and how to state your conclusion in section 3, right? So if you conduct an independent t-test, how do you state your conclusion? If you conduct a pair t-test, if you conduct, so pay attention on how to do that. We have a lot of example on that on the homework, okay? Yeah. Can you, okay, let me do that then. Mm-hmm. So that's what I was saying exactly. Okay, but I was just giving a plan. Okay, what's your name? Huh? Oh yeah, it's in learning. Is it grind or something like that? Yes, yes. Please see me after class, okay? All right. So I've just explained that, like what you just asked about. I've just talked through them. I just explained that. So if it is not still clear, let me repeat very briefly. Each section will be presented, you know, in line with what is being what this section is focusing on, right? So again, if it's focusing on concepts, it will be multiple choice, but it's focusing on logic questions, it will be something similar to what we did in quiz 2. Okay, so section 2 is more or less some like concepts, right? So the questions there will be maybe multiple choice, maybe answers to fill in. Yeah, so, but I don't want you to take the review as the exact reproduction of the questions you're going to see in the exam, right? They are going to be, so for example, this review contains 3 questions or thereabout on binomial distribution, right? One of them is that, I mean, like, these are the questions we have on the homework. So something like that is going to come out, right? But I could structure it slightly differently. Like I could change the format of the question slightly differently. But where concepts are tested, take for example, if you're asked to calculate the mean, there's no other way to calculate the mean other than just calculate the mean, right? So questions like that could have multiple choice because there's only one way to do that. But if, for example, I'm asking you to do interpretation of a result, there is no particular way of interpreting, right? There is no specific way interpretation must be done, you know. So a question like that will be more flexible. Okay. Any other concern before we move on? Okay. So let's go ahead. So if after the end of the day, you have a question that you feel like, you know, scientific calculator is going to become like central. You know, for example, we couldn't solve p-value. There's actually a way to calculate p-value to solve it, right? But we didn't do that. We used Excel, you know, so those tools are coming in situations where it's impossible to do otherwise. You just have to use some tools. So if you're able to show me an example of the questions, send me questions where a scientific calculator is a tool you can use. For example, say you can't find p-value by calculation. You have to use Excel to get it, right? If you're able to show me something like that, then I could waive the idea of scientific calculator and we can use it. But I know that not everybody has it, but we'll see what we do if that becomes the situation, okay? Any other concern before we move on? And I hope this is recording somehow. Okay, so we'll start with the first one, okay? Section 2 includes 3 topics, right? And I think I should have a new page where we write these things down so that it will be a guide. And we might not cover everything here today. Wherever we left out, we'll pick up next class. So section 2, the questions are not going to be tricky. They're not going to be, they're just going to be what you should expect if you review properly, okay? So section 2 covered 3 topics, covered binomial distribution, it covered normal distribution, and then it covered as part of normal distribution, but the focus was central limit theory. Okay. Yeah, so this section 2. So I'll just go into this section and try to look at the homework and make up some, maybe about 5 questions from 3 of this, right? So by the time you check 5 questions from this section, you have a minimum of 20 questions, and then there could be more than 20, right? Okay. So let's start with the first one, which is binomial distribution. That is what the first review here is showing you. So it says, a binomial experiment consists of 13 trials. The probability of success on trial 6 is 0.87. What is the probability of failure on trial 10? Right, so just saying, okay, so first you remember what a binomial distribution is like, or what is a binomial experiment, right? So remember, the key thing we talked about here is that there will be 2 outcomes only. So there is only 2 outcomes whenever you're dealing with binomial distribution. Okay, so I've given them topics here, but of course, you know, on the final exam, you're not going to have the heading binomial distribution. You're just going to have a question, but it's left for you to use what we're explaining and to tell that this is a binomial distribution and solve it that way. So first, you have 2 outcomes. So this will be something like yes/no. This could be something like true/false. This could be something like good/bad, right? So you have this, any scenario where you have 2 options, rain or it might not rain, any scenario where you have 2 options like that, that is the binomial distribution, okay? So, but this question is not describing the scenario, it's just telling you directly that this is actually a binomial experiment. So that logic goes off. but you might have a question that will make you think. Ask yourself, is this a binomial distribution? And how do you know? The first thing to note is that if you read the scenario, the outcome, like what will eventually come out of that scenario, can only be two. So if somebody's saying, what is the chance that it will rain today or it will not rain today? What is the chance that a product is defective or the product is good? What is the chance that the answer is yes or no? What is the chance that if I flip a coin, what will be the result? There are only two possible things that could happen, a head or a tail. So if you see any scenario where the outcome, the result of that experiment can only be two, then you have a binomial distribution, okay? That's the first thing. The second thing is that the probability of success is constant. Right? And what does that mean? That simply means the probability of success doesn't change as you go along. So take, for example, if I flip a coin 10 times, the chance of getting a head is always 1/2. It cannot change because I flipped it 2 times or 3 times, right? So that is binomial distribution. Because whenever you flip a coin, there are 2 possible outcomes binomial. If each time I flip it, the chance of getting a head or a particular outcome that I desire, the chance is fixed. So the probability of getting a head anytime you flip a coin is always 1/2. So if you have a scenario like that, then you have a binomial distribution. Then the third thing is that the probability of getting, so let me use success and failure here, right? So because that is the term normally used. Probability of success plus probability of failing is equal to 1. And that is like the nature of binomial distribution. So you have to get one of them. It has to be this or the other. It can be anywhere in between. So because this is true, we normally represent success in the formula with P and failure in the formula with Q, right? So you see that P plus Q is equal to 1, right? So in the formula, if you know P, you can get your Q. So if I say P is, for example, 0.3, then automatically I know that Q is 1 minus 0.3, right? So Q is 0.7, okay? And then of course, remember finally that probability ranges from 0 to 1, right? You can't have anything outside of that. So if you're solving a question in probability and you get an answer that is above 1 or that is negative, that is a red flag that you've done something not correct. Okay, all right, so let's look at this question. From what I've explained, this question is actually trying to test one of these concepts, right? So look at what it's saying. A binomial experiment consists of 13 trials. So let's say this binomial experiment is flip of a coin. So you're flipping a coin 13 times, okay? It says the probability of getting a head, let's say a head is our success. The chance of getting a head when you flip it the 6th time is 0.87. Then it's asking you, what is the chance that when you flip the 10th one, what is the chance of also getting a head? So if you follow this, you see that this is simply testing. Let me change another color here. This is testing red. This question is testing this second concept. It's trying to check whether you know that the probability of any outcome in binomial distribution is fixed. It doesn't change, right? So if the 6th flip, when I flip the 6th time, the chance of getting a head is 1/2. When I flip the 10th time, the chance of getting a head will also be 1/2. That doesn't change, right? So this simply tells us that the answer to this question is the same thing as this one. So if the 6th trial has this probability, then the 10th trial or any other trial will have the same exact, hold on, let's see. Oh, okay, I didn't pick, I think I missed something there. Sorry about that. Okay, so but the explanation I've given is not really wrong, but it doesn't, that's not what it applies in this concept. Okay, so the 10th time, the same probability of success will also be 0.87, okay? But then this question is really trying to test this concept here. Okay, so it gave you the probability of success and it's asking you for the probability of failure. So the trick here is just to change the attempt number, right? So it's saying if I attempt 6 times, the 6th time and attempt the 10th time, what is probability of success on the 6th time is given to us as 0.87. Then the question is, what is the probability of failure on the 10th time? So it doesn't matter the time I'm trying, the probability of success is fixed. And because probability of success is fixed, it also means probability of failure is also fixed, right? So we said here in this part here that probability of success, probability of failure is always 1. It's always equal to 1, okay? And I just worked out here that if you know success to be 0.3, then failure will be 1 minus 0.3, right? So for this question, we're just going to say, okay, we know that P of S plus P of F is equal to 1. And so if we're interested in P of F, we know that that will be 1 minus P of S, right? So we're simply going to solve this by saying this is equal to 1 minus 0.87, okay? And when we do that, that will give us 0. What would that be? 13, yeah. 0.13. Does that make sense? Any question on that? Okay, so let me give you an example of how I set the exam. So what I will do is to open this homework and say, okay, in this question, you were asked to tell the probability of failure when success was given to you. So I could do 2 things, right? Or number of things. I could say, okay, let me flip it around. Let me give you the probability of failure and ask for probability of success, right? Or I could say, okay, let me give you the probability of failure and success on the same question, same number, the same trial. Because this is 6th and 10th, I could make both of them 6th. Just tweak it a little bit, but we're testing whether you understand these basic characteristics of probability of binomial distribution, right? One is that the outcomes are 2, always, not more than 2, and then the probability is constant, and the sum of probability of failure and success is equal to 1. And once you have that understanding, you'll be able to apply it to answer this question, okay? So this is the kind of question that will lend itself to multiple choice, you know, or maybe imputes the correct answer. You just have a space where you impute that. Any question on this one before we move on? Okay, so Okay, so let's go to number 2. Number 2 is also still binomial distribution, and it's trying to also test something else, right? It's saying here that according to American Red Cross, 8.6% of all Connecticut residents have type B blood. A random sample, bless you. A random sample of a random sample of 24 Connecticut residents is taken, and that random sample is denoted by the capital letter X, right? The question is, what is the standard deviation of the random variable X? Okay, so this question will be kind of taking that you know how to calculate standard deviation for a binomial distribution, right? So if you remember when we did that, and I will write the formulas for starting with mean. The mean of a binomial distribution is just n times p, right? The number of sample size times the probability, okay? The variance of a binomial distribution is n times p times q, right? So the number of sample size times number of trials times probability of success times probability of failure, right? Remember that we said here P and Q are used to represent success and failure, right? And the sum of the two must be 1. So if I have one of them, I can get the other one. And then, as always, you know that standard deviation is often what you get when you take the square root of the variance, right? So whatever is your variance, take the square root, you get your standard deviation. So standard deviation will be as n times p times q, right? So, but we look at the format of this question, and this is one of the things I'm not going to be doing on the exams, and we never did anything like that on any assessment. I'm not going to give you like square roots or have your final answer to be an intermediate answer, because what they did here was to place the answer as an intermediate answer. So in essence, what this question simply wants you to do is to solve the standard deviation and leave it as square root of whatever is your n. In this question is 24. Whatever is our p, probability of success, in this question is 0.086. I hope you can see that, right? It is 8.6% success. So if you divide that by 100 to get it to a decimal number, you have 0.086 times the probability of failure, which is the complement of this, and you normally would get that by 1 minus probability of success. So we're going to do 1 minus 0.086. Okay, so this is what you have. It's simplifying this that gives you that answer, right? So we go ahead here and do, this is square root of, okay, so let's do 1 minus 0.086 first. So we have 1 minus 0.086. We have 0.914. Right, so here we are dealing with 24 times 0.086 times 0.914, if I remember that correctly. Let's confirm that. 0.914. Okay, so now I multiply everything. So 0.914 times 0.086 times 24, everything gives me 1.886496. 1.886496. I hope I got that correct. All right, 1.886496. Okay, so that gives me that in a square root. So what I see is that in this homework question, the final answer is kept as a square root. So it matches this one, right? Which is, where is that? Which is this, right? So I'm leaving it that way. So this is one thing you're not going to expect to see in the finals. I'm not going to let you do your answer intermediate. If I ask for standard deviation, then I expect you to actually take the square root of this number and get a final answer, right? So just take the square root of that, and you have your final answer to be 1.37347 and so on. Okay. And then the instruction on the final exam will say work with 4 digits. Please do that. That way we don't have rounding off errors. So if I'm working with this number, I'll keep using 4 digits wherever possible. But you know it's not possible to use 4 digits here, right? 4 decimal places. It's just 3 already by itself, so I can't make it 4. You know, this is already 3 digits. I can't make it 4. But the final answer, for example, is more than 4. So just work with 4 digits all the time. So if I'm going to take the square root of this number, I either take the square root of everything the way I have it, or I take the square root of at least 4 decimal places, 65. So I'll take the square root of this at least. So like when you do this, your answer will always match. You won't have round-off error, okay? So that way I can grade consistently. So use 4 digits when you're working, all true. And if possible, leave your answer as 4 digits. That is fine. So in this question, what do I do in the final exam in this kind of question? I will just look at this and tweak it. I could ask you for variance instead of asking you for standard deviation, right? I could ask you for mean instead of asking you for standard deviation. You know, yeah, something like that. I could change the format of the probability. It was given here as a percentage. I could give it to you as a decimal number, right? I could give you 0.086 as your probability, right? Instead of giving, so here we are giving the probability of success. I could start to give you the probability of failure instead of probability of success. To know if you understand the concept that if I have 1, to get the other one, I just subtract it from 1. Right? So these are the way to set this exam. Then I can create a different scenario that will make it sound different. So I'm testing whether when you're reading this scenario, do you actually understand it is binomial? Because you have to understand it's binomial first, then you decide on how to solve it, right? And of course, you have your formula sheet. So I will expect that you already have this formula somewhere written down, and as our practice, if you have any formula that you can't remember or that you didn't write down, just ask me, I'll write it on the board for everybody, right? Okay. So, but sometimes I don't want you to take the cue that I write the formula on the board to mean that it is a formula you need, because the person might be asking me for a formula that is not actually needed, right? But whenever I'm asked for a formula in the exams, I'll write it on the board. That way we are treating everybody equally, okay? Any other questions or concern about this one? Okay, so we move on to the next one. The next one here is also a binomial distribution, and this one is actually trying to make us do some kind of calculation. So let's solve one. Okay, so it says the fair coin is flipped 10 times. Okay, we talked about a coin today. Find the probability that more than 8 of the flips turns up tails. Okay, give your answer to 3 decimal places. So I will try to avoid having instruction like this on the assessment, right? So just work with 4 digits all the time, everyone. All right, so here, I expect that you remember that the probability of getting any outcome is fixed at n factorial over n minus x factorial times x factorial, x being your success, right? Times the probability of success raised to power of number of success times probability of failure raised to power of n minus x. This way, right? Okay, so you have the formula with you. The rest is just plug in and solve. So for this one, I know that it will become tedious if I give you numbers that are weird. So I will select the numbers carefully such that you can easily calculate them by hand, really, very easily, right? So let's do that here. So very quickly, 10 factorial will be, n is 10, right? Okay, so let's list those items. N is 10, isn't it? X is 8, right? Not 8. Okay, so can somebody help us here? What do you think is X in this question? X is the number of success. And remember, success is the outcome you desire, right? So this question is saying, find the probability that more than 8 of the flips turns up tails. Any suggestion of what that X or what that success will be? Or like, what is this question? What is the number of tails that this question is expecting to have as the outcome? 9, very good. So more than 8, so 8 can be, it is more than 8. So it is 9, but is it only 9 and 10? Because more than 8, anything more than 8 will work here. So the probability of success here is that you're looking for either the person get 9, that is what the question wants, or the person gets 10. Okay, so how do I tweak this question on the exam? I could say no more than 8. That's a different thing, right? No more than 8 means it could be 1, 2, 3, 4, 5, 6, 7, 8, but not more than 8, right? And all that kind of, less than 8, equal to 8, right? Equal to 8 means I just want the probability that it is 8 and nothing else, right? Okay, so take note that this formula gives you the probability that it's a particular number and nothing else. So if this question is asking us to find the probability that our result is greater than 8, when we know we actually have just 10 trials, then our answer with probability that it is equal to 9. Let me write that very well. The probability that is equal to 9 plus the probability that it is equal to 10, because this will represent more than 8, since we have maximum of 10 trials. So what you need to do is to use this formula to solve each of them, right? And then we're going to do that very quickly. Okay, just a moment. Someone is supposed to join in remotely. I think I need to make him in, let's be sure. Okay, so it's not that. All right, so what's the probability of getting 9? So let's solve that very quickly. Probability of 9 will be n is 10, right? So I have 10 factorial divided by 10 minus 9 factorial times 9 factorial, right? X is your 9, right? Then this will be multiplied by probability of success. So this is another thing that we need the reasoning in. So if I flip a coin, I expect that you know that the probability of success should be 0.5 for every flip, right? Whether you're thinking about head or tail. So you see that it was not given to you here, but it's expected that you get that from the question. So I have here 0.5 as probability of success, that is my P, and I'm going to raise that to power of X, which is 9, right? Times the probability of failure. So again here, I know that probability of failure is 1 minus probability of success. We already talked about that in previous slides. So it happened to also be 0.5, right? And I'm going to raise that to the power of n minus x. Okay, so how do I solve this very quickly? The numbers I've been choosing to make it easy to calculate. And the ones you have on the assessment will be easy to calculate, right? If this question is coming out. So let's start with this section. Right? You remember your factorial. Your factorial simply means multiply from that number down to 0. So 10 factorial will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, that is what I have on the top. And then here on the numerator, I have 10 minus 9, which is 1. And 1 factorial is just 1 because there's nothing else to multiply. Sorry, I said earlier multiply to 0. You actually multiply from that number down to 1. Okay. So what I have in parentheses here, use a different color. What I have in parentheses here is simply 10 minus 9, which is 1. And 1 factorial is just 1. So I don't do anything more. Then I will look at 9 factorial. 9 factorial will be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So when that is what you have, it is very easy to see that all of this goes away with all of this. Your answer in this section is simply 10, right? So the question will be such that if you want to work it manually, fine, but as you're solving, you're going to see the whole thing fizzle out and you have very simple numbers to work with, okay? So we have 10. So if you are doing this and you start getting something complicated, just know that something is wrong somewhere, right? So we have 10 as the outcome of all of this. So when we want to solve probability of getting 9, then we are simply doing 10 times 0.5 raised to the power of 9 times 0.5 raised to the power of 1, right? Because 10 minus 9 is 1. So I will just have that. So this is what we have. And the biggest thing here for you to do is actually this one. Every other thing is straightforward, right? I mean, I know what 10 is, and you know what you get when you multiply any number by 10. But what you should also remember, and we did this when we're solving this topic, you can write it down as part of your formula sheet, right? Remember that anything raised to the power of 0, let me use x, okay? X is normally what you use in representing variable in mathematics. Anything raised to the power of 0 is equal to 1, and anything raised to the power of 1 is equal to the same thing. Right? General principle, and you can always apply this anytime. Okay, so let's go back here. So I see that automatically this one resolves, very straightforward. 0.5 raised to the power of 1 is 0.5. And the raised to the power of the 1 is the same thing. So the only thing I really have to deal with is just this section, right? Okay, 10 is there, of course. So I have 10 times 0.5 raised to the power of 9 times 0.5. So I can take away 0.5, first. So if I take away 0.5, this one first, so I could have 10 times 0.5, like multiply this to here. Then I have 5 times 0.5 raised to the power of 9. Okay. So I would, in the assessment, because if this is homework, I'm okay with this question. But in assessment, I will know that, just as the way we choose 3 data points, I know that you don't have time to start like having a lot of numbers. So I'm going to choose a number that is small, so it won't be raised to the power of 9. But even if it's raised to the power of 9, we can easily do that. It's just say multiply 0.5 itself 9 times, right? And some of the 4-function calculator might able to have, okay, this one has square, so I can actually use that. But let's just do it manually very quickly. So I have 0.5 times 0.5 times 0.5. That is actually 3 times so far, right? I'll do another set of 3. Okay, let's start all over. 0.5 times 0.5 times 0.5, that is 3, times 0.5 times 0.5 times 0.5, that is 6, times 0.5 times 0.5 times 0.5, and that should be 9, right? So if I do it 9 times, this is what I actually have, right? Multiply this by 10, so times 10, this is what I have, 0.01, right? So if I look at my answer, but let's write it down and then see how we approximate to the answer. Over here, I have 0.0195. So let me take this forward, that will be okay. 0.0195, okay? So this is, on the assessment, I expect your final answer to be this, the 4 digits, right? But just to match it with the homework, the key says 0.011, right? So if you approximate this, 5 is up to, you call 5 1, right? And add it to this, that will be 10. So that gives you a value close enough. So I think they use the entire sequence of the number you get when you actually raise this to power. Okay. So yeah, but the answer will come out that close, very, very close. If I'm giving you this on assessment, I'll give you numbers that will be simple enough that the answer will match, almost the same thing. But all the same, when I'm grading, I'm also going to make allowance for such thing as that just happened here. Okay. And I hope I wouldn't make any mistake anyway. Okay. So what I expect is that at least in the first decimal place or the second decimal place, we should have the same thing, right? If there's a difference, it should come from maybe as from the 3rd decimal place going forward. Okay. All right. Any question on this one? Oh, okay. I see what happened. We're not actually done though. We're not done. Okay. So this is what I got, and I want to represent this as 4 digits. This is for 9. Excuse me. This is for getting 9, right? Then we need to get also 10. We just solved this one. We just solved this. We need to also solve this one. Okay. And so when I see questions like this on the assessment, I will avoid making you do a lot of work this way, right? It will be short, because what I'm testing is what I just did. So beyond this, doing more work will not work. So if I have this question on the assessment, I will say, what is the probability that is greater than 9? That way you just have one thing to solve, okay? So let's go ahead and do probability that is greater than 10. Okay, I'm trying to move this down. Let's do the probability that is greater than 10 and then add those two together, right? So let's do the probability that is bigger than 10. So P that is equal to 10 really is, again, 10 factorial divided by 10 minus 10 factorial times 10 factorial, right? Remember your X is 10, right? So we're plugging into this formula here. So this is what I've got. And then I'll go over here and do times 0.5 raised to the power of X, which is 10, right, times 0.5 raised to the power of n minus x. Okay, all right. So again, this will simplify just like the other one, very, very easily, right? So let's look at this first. So if you look at this part, you actually just have one, right? You have a question, yes? Mm-hmm. 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 I did not use the 5. Where is this 5 here? Uh, okay, okay. Thank you for that, for pointing that out. So in essence, what we are saying is that what we have is 0. Okay, let me see. 0.0195 is coming from raising 0.5 to the power of 10. Okay, thank you. So we are multiplying that by 5, really. Okay, tell me what you got again. Say that again. Yeah, what you're saying is right. So, I mean, this is this times this, right? So if we didn't do this, if we didn't multiply by 5, then that is an omission. If 9766, right? Okay, so let's quickly confirm that multiplying over here. Okay, so just multiply this by 5, and you have 0.009766. So that is correct. And thank you for pointing that out. And I hope that is actually a mistake that we made. Okay. All right. So if you've taken care of that, you need to do that of 10, right? So for 10, I was going to say that all of this is actually just 1, and we can see that. Another observation, yes. Oh, okay, okay. Thank you for picking that as well. So let's write that back again. So this is, let's look at the calculator to be sure. This is 0.09765. 0.09765. 0.09765. And we round off to 66, okay? Okay, thank you for observing this, right? So let's go ahead and do the second one very quickly. Okay, okay, okay. Given what you're saying now, anybody else have the same observation as Melly? You got the same thing? Let's repeat this line, right? So the complaint, I mean, the differences in calculation we are having is coming from this line. Is that correct? It's coming from here. Is that correct? The differences we are having in our final answer is coming from this place, isn't it? Mm-hmm. Mm-hmm. Okay. 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 So let's repeat that again very quickly. Okay. So maybe that will just clear that up. So when you're working like this and you make mistakes like this is why it's important you have your scratch sheets, right? Actually stop on your scratch sheet so I could see where this happened and quickly correct it, because it's human, it's bound to maybe happen. But the question I'm going to give you will not make you solve all this. It will make you reproduce just very few numbers that will not take it. So let's do that very quickly again. 0.5 times 0.5 times 0.5. This is 3 times, right? Times 0.5 times 0.5 times 0.5. This, I believe, is 6 times, right? 0.5 times 0.5 times 0.5. This, I believe, is 9 times. Okay, so what we are saying actually is that here, in place of this, we got 0.001953. Okay, so let's clean this up. Actually, delete it. That will be quicker. Okay, so we have here 0.00195. Okay, so we end up having here 10 times 0.00195. Okay. Okay, that is big enough, right? Just if you have up to 4 decimal places, that is big enough. Times 0.5. Okay, so before we said let's remove 0.5 times 10, that will give us 5, right? And so we have 5 times 0.00195. And so the other mistake was that we didn't multiply with 5, right? So let's be sure we do that now. And I can leave the value on my calculator that way and continue working, right? Times 5, that gives me 0.00976. Does this agree with the answers you have? Yes. So 0.00977, really. Okay. Okay, thank you. Any other observation on this question? Okay, so again, work on your scratch sheet. So that way, if there's a mistake like this, I can easily pick it out and give you credit for every other thing, right? Because if you miss something like this, I will know it's not concept. It is just human error. So that could be very minimal versus, I don't know that this is what I'm supposed to do. That is entirely different, right? Okay, so use your scratch paper during the assessment as much as possible. So we're talking about solving the next one, which is probability that x is actually equal to 10, right? And if we do this very quickly, we have 10 factorial all over 10 minus 10 factorial, right? Times 10 factorial times probability of success is 0.5 raised to the power of number of success, which is 10, times probability of failure is 0.5 raised to the power of 10 minus 10, right? Okay, so in previous up above, when we were looking at simplified expression, we saw that anything raised to the power of 0 is 1, right? And that will be the one that will apply in this case. So we have so you could see here that this 10 factorial, and just take note of that. This 10 factorial, I can cancel out this 10 factorial here. So they are all gone, right? 10 minus 10 here is 0. So actually you have just 0 factorial here. 0 factorial is 1. So let me add it to the symbol, the simplified notation we have here. So 0 factorial is equal to 1. Right? So in essence, the whole of this resolves to 1. Everything here just resolves to 1. So we just have like 1 times, let me switch back to red. So we just have like 1 times, okay, so let's look at this one also at the same time. Make it green. Let's look at this one also. Right? This is 10 minus 10. So this is like 0.5 raised to the power of 0, right? Because 10 minus 10 is 0. And we know that anything raised to the power of 0 is 1. So this one also resolves to 1. So this will be this times 1. Okay, let's say 0.5 raised to the power of 10 in the middle times 1 also here. Any question on this point? Yes. No, it will be 1, right? So like any number divided by itself is 1, isn't it? Does that make sense? Like let's say 2 divided by 2 is 1. 10 divided by 10 is 1. So 10 factorial divided by 10 factorial is 1. Right? So everything there becomes 1. Okay, so good observation there. So once you're dividing anything by itself, the result is 1. So 10 factorial divided by 10 factorial is 1. So we have this, and then we're focused on 0.5 raised to the power of 10. I can actually produce that answer from the previous slide, right? I could do, we remember that this is 0.5 raised to the power of 9. We recall that, right? So I will just multiply with 1 more 0.5, and that will give me that answer, right? I know, but you can do it all over again if that is the case. So let's do clear this. 0.00195 times 0.5. That gives us 0.00975. So let's shall we capture the number of 0 this time. So it's 3 zeros, then 975. So I have 0. Let me be consistent with you. So I have 0.000, then 975. Okay, so this is what I actually have, because of course, anything multiplied by 1 is the same thing. So I just kind of ignore those other ones. Questions, observations about what is not, maybe something we missed along the line? No. Okay, so now I'm done. Again, in the assessment, so this is homework. So the question was structured to give you time because you have time to work. In the assessment, I'm not going to make you do 2 of this, right? I could structure the question in a way that it will make you do, 1 or thereabout, right? So, but it could also be 2, but if it is 2, it's not going to be involving numbers this way, right? It won't be raised to the power of 10. It could be raised to the power of 2 or raised to the power of 3, something that you can do quickly, okay? All right, so on the final answer, we know that we are looking for probability that x is greater than 8. And we know that this is probability that x is equal to 9 plus probability that x is equal to 10, right? And we got the probability that x is equal to 9 to be 0.00977. So we have 0.00977 plus the probability that x is equal to 10, we got 0.000975, right? Can you all help us add these two together? What do we have? We can do it here as well. All right, 0.00977, right? Plus 0.000975, gives us this value here, right? Okay, so we have 0.010745. So we have 0.010745. And I hope that is 0.010745. Okay. So of course, if you run this to 3 digits, but on the exams, again, everything is in 4 digits. So I expect you to keep your answer in 4 digits. So if you run this to 3 digits, you have 0.011, which is what matches the key. Okay. Okay, so take note of where we kind of made some mistake in computation here. Again, that emphasizes for us the importance of using your spreadsheets, right? Because if you have your spreadsheet, I can easily see where the problem lies if I go through them, and then not penalize you unnecessarily, right? So for example, if you write 1 + 1 is equal to 3, I know that you know that 1 + 1 is 2, so I know that is human error, so that could be overlooked, right? But if you don't recognize that this is binomial distribution and you work something else differently, then that is, something that will be penalized, right? Okay. So any concern about this one? So again, on the assessment, just like we do in data, right? I normally will give you 3 data points, so it's not going to take you multiple things to work on assessment. If this question is one of the ones you have, or a question like this one is one of the ones you have, then it will not be such that you will have to solve multiple times to get the answer. It will not be such that you have to raise the power of 10 or power of 9. It will be that you just raise the power of 2 or 3 at most, okay? That way you can easily get to your answer. But that's what we're testing, the knowledge that you know what to do, not that you know how to do the calculation, okay? So if you can solve this, and that is why the homework is a good way to practice. If you can solve the questions on the homework, you can actually solve the question on the assessment because it's going to be way easier than the one on the other, right? In terms of what you have to do to get the answer. Okay. Any other concern about this one? Okay, so the next session on this will be normal distribution, right? And I have 2 questions here to highlight that, but definitely we can cover all that today. And then the last section, of course, will be those hypothesis testing, either, what is it called? Either confidence interval, 1 sample mean or 2 sample mean, right? Okay, so for the rest of the 5 minutes we have in class, we're going to pick up this one next class. For the rest of 5 minutes we have, let me highlight the SPSS output, okay? So for 2 parts in the finals, those 2 parts we focus on SPSS. And the first part will be linear regression, right? And we did that, we covered that in section 4, chapter 11, unit 11. So I'm going to go to unit 11, and then you have your linear regression, right? What I have done is that the answers are already posted here. I know that some of you are still working on this, but the focus in this section is that you are able to implement this. Know that this part will be tested on the assessment, so that you have the answer here doesn't really matter on the homework, right? So open this up, and let me talk through exactly what you are expected to do on the finals, or what is expected of you. Okay, it's taking a while to come down. Okay, so this is what you have, right? So when we're going through this, we have all this, I think opening a fully will be better. We have all this output. So on the final, what I expect you to do is to be able to understand the output, isolate them, right? So for example, on this output, we have R squared here. I want to know that you know what is R squared and you know the interpretation for R squared, right? We have the coefficient here, the constant here, and the coefficient for anxiety here. In this context, I want to know that you are able to write the equation, the regression equation, using these items here. The regression equation is here. I don't know if you can see that clearly. So let's make it bigger. Yeah, so that is the regression equation, right? So I want to be able to know that you can produce this regression equation. If you don't have it, that you can actually produce it using the output. Okay, if you watch the video in this section that we did in class, we did all I'm talking about, right? So interpret R squared, interpret, its meaning and all that, be able to write the equation, right, in the context of the problem, and then be able to answer questions like the one we answered here. So if you just review this, we did this in class, but I also posted it here. This is a solution to the one you were given as an assignment. If you just review that, you'll be able to get the kind of questions you'll be having on the exams. It's just going to be something like that. Then the same thing happens on 12, on one-way ANOVA. We have just a minute. I've also posted the answer key here, right? So a similar thing, if I have this one-way ANOVA, am I able to kind of pick up items from the table, from the output, and say what they are, right? Am I able to, do I understand what is meant by, this is just descriptive, so no question from there. Do I understand what is meant by test of homogeneity or variance, right? We're going to be interpreting only the first line. Do I know how to interpret that? We did that on the video. This is your ANOVA table. When do I interpret the ANOVA table? Or when do I interpret the robust table? So you watch the video for this section, you see all that. What is the effect size? How do I interpret it? It's also on the video. So I'll put up all these answers here. So the last 2 sections, I think, is something you can easily pick up. How do I interpret multiple comparison? They are all there. We did all this in class, and they are all there in the video, right? So if you're able to do that, you find you have easy way on half of the assessment. 50% of the assessment is just doing what I've just done. And you have this here, and I've also produced them in video. Okay. So when we come back next class, we'll pick up the remaining parts of section 2 and 3 that we'll not cover today, and we'll be able to finish up that. All right, so our time is totally off. We have 1 minute over time actually. So please just mark. All right, so where do I stop this one? Okay, I know the recording is still going on, but I'm not sure. Okay, I think I'll find it. Yes, please. The quiz.